Tool calling is extremely important for many LLM use cases, and I found that many people have a perception that local LLM models are not good at tool calling. However, in my experience, a lot of the poor results people see are actually due to issues in their environment setup. In this video, I'll talk about some critical factors to keep in mind to get better results out of tool calling with local LLM models. This includes the decision on what application to use for inference to host your model, settings like temperature and top P, the use of quantized models, the system prompt, the context window size, the need to keep your inference application and model up to date, and then finally we'll cover an optimized configuration to help get better results with tool calling with local LLM models. In this video, I'm using the unsauth version of GLM 4.7 Flash. However, the principles I'll talk about apply to other models as well. Let's start with one of the most important decisions you need to make, which is determining which application to use to host the model. This can have a huge impact on the success of your tool calling results. And in this video, we'll look at the difference between using Ollama and llama.cpp. In my testing, using GLM 4.7 Flash with Ollama for tool calling doesn't work well. And in the unsauth guide for GLM 4.7 Flash, they note that they don't recommend using Ollama currently. Let's try this out with Ollama just to show how much of an impact this can have. I'm using the latest version of the Ollama container from Docker Hub, and I'll start the container with Podman. Then I'll open a shell in the container. I've already pulled the Q8 version of the GLM 4.7 Flash model, and we'll make sure it's at the latest version. In all the examples today, I'm using Goose along with the linux-mcp-server, which is an MCP server that can connect to remote Linux systems. Within Goose, I've configured it to use Ollama with the Q8 version of the GLM 4.7 Flash model. I'll use the same prompt in all the examples so that we can easily compare results. I'll let the model know that I have 3 systems named Fedora 1, 2, and 3, and ask it to check the health of these systems and report on any issues that I should look into. The Linux MCP server provides a number of tools that the model can use to gather this health info. As you can see, the model looks like it wants to call some tools, but it just isn't able to make any tool calls, and finally gives up. If this is all I had tried, I might walk away at this point and think that GLM 4.7 Flash isn't good at tool calling, when in fact the issue is that Ollama is not currently recommended for use with this model. The key takeaway here is that there are a number of options for hosting local LLM models, including Ollama, vLLM, llama.cpp, and others, and that you should experiment with these various options to see which produces the best results for a specific model and use case. Next, let's try it out with llama.cpp. Unsauth has a guide on how to run many models locally, including GLM 4.7 Flash. It's highly recommended to read through these guides so you can identify the recommended settings for tool calling use cases, and we'll come back to this later. But a common mistake is not reading through all this, instead just running the model with the default settings. Let's see what happens when we just take the default settings with the Q8 version of the model. I'll use Podman to start the llama.cpp container without specifying any settings related to things like temperature, top P, min P, etc. We'll just go with the defaults for all those. Let's jump back over to Goose, where I've already configured it to use the Q8 model hosted by llama.cpp. I'll use the exact same prompt we used before to check the health of the 3 Fedora systems. The good news is that at least now we are seeing some successful tool calls. The model starts by using tool calls to collect info from Fedora 1 host, which includes system info, CPU info, memory info, disk usage, listing services, getting network interfaces, getting listening ports, and listing the processes. The bad news is that the model starts repeating tool calls that it's already made. For example, it calls the get disk usage tool and get system info tools a second time for Fedora 1, repeats another call to the get network interfaces for Fedora 2, etc. There are a number of these types of duplicated tool calls which really aren't necessary or ideal, as they're basically just wasting time and taking up more room in the context window. It's also interesting that it started by making 8 tool calls in parallel to collect the info from the Fedora 1 host, and for Fedora 2 and 3, it's making all the tool calls one at a time. It eventually gets done making a lot of these duplicated tool calls and shows the results and provides info on the health of the systems. So with the default settings, we saw some tool calling success, but we had a number of duplicated tool calls, and we only saw parallel tool calls to collect info from one of the 3 systems. So the key takeaway here is you definitely want to review the recommended settings for the model you're using and for the use case you're using it for. Next, let's see what happens when we use a heavily quantized Q3 version of the model. Quantized models are smaller and require less GPU resources, but the trade-off is reduced performance. Let's start llama.cpp with the unsloth Q3 version of the model. Don't worry about the other settings. We'll talk about them in more detail later, but just know that these are the recommended settings from unsloth. So this is a test of the Q3 model using all the other recommended settings. Let's jump back to Goose, and I've already configured it to use llama.cpp with the Q3 version of the model. We'll use the exact same query and have it check the health of the 3 Fedora systems. Right away, we can see it made a lot of tool calls in parallel to collect info from all 3 systems, which is an improvement. But then we see it make some duplicated tool calls to the get system info tool, which it had already run. Another thing to keep in mind is that not only will the tool calling results be negatively impacted by the Q3 version, the performance of the model interpreting the results will also be negatively affected. The key takeaway here is if you're looking to get top performance from tool calling, you definitely want to use the lowest level of quantization possible based on your available hardware. The context window size can also make a big difference when using tool calling. If your context window is too small for the types of tools you're using and the number of tools calls you need, you're probably going to see some issues. Previously, I've been using a 75,000 token context window. Let's try running the model with a 15,000 token context window to see what happens. I'll use the -C option to specify this 15,000 token context along with the other recommended settings that we'll cover in more detail later. Back in Goose, I've already configured it to use the Q8 model. Let's use the same query, and we'll see that it makes a number of tool calls in parallel to collect info from all 3 servers. So far, this is looking really good. However, we then get a message that the context limit was reached and that it's compacting to continue the conversation. And then I get an error message that it failed to load the session. So the key takeaway here is that you need to make sure your context window is sufficiently sized for the types of tools and the number of tool calls you'll be using. Okay, let's take a look at the unsloth guide again and see what settings it recommends for tool calling. In here, it specifies that for tool calling, we should use a 0.7 temperature and set top P to 1.0, and that we should set the repeat penalty to 1.0 as well. A little further down, it also specifies that we should set min P to 0.01 and also use the --Jinja option. So let's try running the Q8 model with these recommended settings and a 75,000 token context window and see what kind of results we get when we are using all the recommended settings. I'll jump back to Goose where I still have it configured with the Q8 version. I'll use the same prompt that we've been using to check the health of my 3 Fedora systems. It makes 18 tool calls in parallel to collect info from all 3 systems at one time, and then follows up with a tool call to get the journal info from Fedora 1. It might have made this extra tool call because it saw something in the previous tool calls where it wanted to get some more details, specifically from Fedora 1. After processing the results, it then displays the detailed info on the health of the 3 systems. So with the recommended settings, the Q8 model, and a large enough context window, we saw some great tool calling results and no duplicated calls to the tools. However, keep in mind that even with these recommended tool call settings, you can still run into issues at times, and you might need to further tune these settings for your specific use case. All right, let's cover a few other tips to keep in mind. Make sure you're running the latest version of llama.cpp. When GLM 4.7 Flash was initially added in llama.cpp, it had a number of bugs that were fixed in the following weeks. If you're running one of these previous earlier versions before the bugs were fixed, you're going to see some poor results. Also, make sure you're using the latest version of the model. For example, Unsloth updated GLM 4.7 Flash shortly after the initial release, which was related to the llama.cpp bugs I was just talking about. This required people to re-download the model to get this updated version for best results. While you're making sure things are updated, make sure Goose or whatever else you're using is up to date as well. Another thing to keep in mind is the system prompt. Make sure it has instructions on using tools. You can try experimenting with modifying the system prompt to be tailored for your specific use case, which might help improve tool calling results. One final consideration is that having too many MCP servers and tools enabled will negatively impact tool calling as well. Only enable the tools you'll need in order to get the best results. Well, that's it for today. I hope this video helps you get better results when you're tool calling with local LLM models. Thanks for watching and have a great rest of your day.